Alright, so now we're going to talk about the hot loop theorem. So this is on page 396 of the book. Again, I'm giving a proof similar to theirs. So if we have a circle of heated wire, variably heated wire, try to get a pin to work, then there is a pair of opposite points where the temperatures are exactly the same. Alright, so say you start here, it gets hotter, 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 colder, hotter, hotter, colder, hotter, colder, hotter, colder, hotter, colder. There's some two pairs of points, say here and here, where the temperatures are exactly the same. Alright, so the way we're going to approach this is by looking at we're going to think of our heated loop as a clock. So we'll make our clock here, and we're basically going to assign temperatures to every point on the perimeter of the clock. And one of the key things of this theorem is that the temperatures have to change continuously. So it's not going to go from 100 degrees at one point to 50 degrees at the next point adjacent to it. Right? It makes sense. If you heat a wire, it's going to be, it's going to the heat's going to continuously change. All right, so we're going to use this notation. Temp x is going to be the temperature, the value of the temperature at hour x. All right, so temp 8 would represent the temperature right here. All right, it could be like, I don't know, 30 degrees Fahrenheit or 100 degrees Celsius. All right, so the 8 is just telling us where it's at, right? There's some value. All right, so temperature 8 could be like, 31 degrees. That doesn't really matter, it's just the notation will kind of help us. So yeah, that's the idea. So we're going to do this by a proof by contradiction. Right, so we're going to suppose we have a clock, or a loop / clock. We're using the clock as an example here, where there are no opposite points with the same temperature. Opposite points with the same temperature. Alright, so that's our supposition. So that means, let's take the temp 12 minus temp, let's look at this value and analyze this. So we're looking at the temperature here minus the temperature there. Alright, it should make sense, it cannot equal 0, right? Because otherwise we would have opposite points with the same temperature. Right, they would equal 0 if they were the same temperature. So without loss of generality, let's just, suppose this is positive. Right, so if temp 12 minus temp 6 is positive, right, that essentially means that, the temperature at 12 is more than the temperature at 6. Alright, so we're going to suppose that. We could do it's negative, it's going to be an analogous argument. Alright, so we're supposing that. Alright, so this tells us temp 12 is greater than temp 6. Alright, so it should make sense that all these points near 12, like here and here, all those points are going to be greater than all of these points. Alright, so points near 12 are going to have a higher temperature than points near 6. Alright, so let's kind of take this to the next step. Let's compare temp 11 and temp 5. Alright, so again, to compare them, we're going to subtract them. So let's do temp 11 minus temp 5. So there's basically three options. So it could equal 0, or that's one option, but that would mean they have the same temperature, so that, that contradicts that. That wouldn't work there. All right, so it could be less than 0. All right, so that means temp 5 would be greater than temp 11. All right, so that means a point here, right? 5 and 11, that means this point, the temperature here is greater than the temperature here. All right, so those 2 points, which, if you think about it, that means, here this is bigger. If this is bigger, then this is smaller. But then all of a sudden here, this temperature is bigger and this is smaller. Since they're changing continuously, there'd have to be a point between 11 and 12 that matches exactly the point between 5 and 6, right? Because it switches from being bigger to smaller. All right, so, but we know no opposite points can have the same temp. So that can't be true, that can't be true. All right, which leaves one thing, that it's greater than 0. All right, so temp 11 is greater than temp 5. All right, so, assuming there's no, unless we have a contradiction, they all have to, it has to be greater. All right, and similar arguments, right, temp 10 has to be greater than temp 4. All right, same reasoning. Point here, 10 and 4. Let's do 10 and 4. Again, we've said, okay, 11 has to be bigger, 5 has to be smaller, otherwise we have a contradiction. So similarly, 10 has to be bigger than 4, right? Otherwise we have a contradiction, right? So temp 10 is greater than temp 4, right? Temp 9 must be greater than temp 3, right? Again, otherwise we have the same contradiction we would have had there, right? So we don't have the contradiction as long as 9 is bigger than 3, right? B for big, S for small. All right, similarly, 8 and 2, big, small, 7 and 1, right, big, small. All right, so we can just add to our list here. Temp 8 must be greater than temp 2. And this is an important one. Temp 7 must be greater than temp 1. Alright. So again, the B's keep... But then if we keep going, we'd have to get temp 6, if you follow the pattern here, temp 6 must be greater than temp 12. Alright? That makes us sad. That is a contradiction, because if you look up here, right, we're supposing our original supposition was temp 12 is greater than temp 6. Right, so this is our contradiction. Alright, so you can see that you're either going to have a contradiction here, you can get around that, but eventually you're going to get a contradiction here. Alright, so therefore our original supposition, this, right, this must be false. Right, so that means there must be a place where opposite points have the same temperature. Alright, so that proves this hot loop theorem. Alright, again, make good notes of exactly where you got lost here and bring it up in class and we can discuss it.